All right, hi y'all. Super excited to be here doing the first talk at our first in-person SoCon, so that's pretty cool. Feel honored. I'm here today to talk about Apeman, which is a project I've been working on to do AWS attack path management. And so first, I'm just going to go over like why why are we doing this, and hopefully we'll convey the problem so that you can understand why we need a solution for this. So at SpecterOps, we do a lot of, or we end up doing some amount of AWS policy evaluation in our assessments. And right now, what that looks like is we pull down this JSON file. If we're lucky and we get the permissions to do this, we'll pull down this JSON file that has all of the users, all of the groups, all of the roles, all of the policies, and we'll evaluate like what we can do, right? And that's if we're lucky. And if we're not lucky, we have about 300 of these, right? That's, I think, the biggest one we've had has had 300 AWS accounts. And really what we're looking for is ways to pivot from accounts from, if it's like a dev to staging to prod or something like that. But every environment has been different. We're doing a lot of string matching, a lot of manual, like kind of in our head, just remembering who can do what. And so, after a while, we got kind of used to it. We're like, okay, grep works pretty well. We're pretty good at this. But it gets really difficult to keep all of this in your head. And so it became really apparent that we need to have some sort of automated tooling for this. And then a couple years ago, we had a client, and I'm kind of ballparking these numbers because I can't really remember exactly. They had about 50 AWS accounts. And I think part of the reason why we drilled in on this problem is we couldn't priv-esc. And so we're like, well, we have to show some sort of value. And they said that they had about 10 org admins. So they're using an AWS org. And with manual analysis of like going through those JSON files, we found that they probably had about 200. And that was a surprise to them. And so, we got to put that in a report and be like, okay, we did our job. But it became, we were kind of floating around this question of like, what is an admin? What is an admin in AWS? Because it's not the same thing as one in Active Directory. In Active Directory, you have an actual admin user and you have enterprise admin group. And these are things that Microsoft provides for you and they're very defined. But with AWS, it's not so defined, right? It's you have the like an admin policy, but even if that's not used, you can have admin users. And what we found is that there's not really words for it, but we found clumps. We found clusterings of roles. So there might be a cluster of something you would call admin, and there might be a cluster of something that you might consider maybe your like DevOps, and a cluster of users. And our goal was to say, how do we automate that so we can find these clusters and build borders between them and say, these are your security boundaries, right? And so that was kind of the impetus of this idea where we would automatically evaluate all of the role assumptions in AWS. That's what we started off with, was role assumptions, and go from there, right? And so we went through, this is like our third iteration of prototypes, where we actually started giving it a name, picked Apeman. But our goals were to be able to effectively analyze an AWS environment and identify attack paths. So the first thing is just, we want to be able to not have to grep anymore for these things. Like I want quick information at my fingertips so that when we get this data, we can say like, oh, what policies are attached to this role, or which roles use this policy, like very quickly, so that we can assess properly, use our time efficiently. And then the second is, what is tier 0 and what are our attack paths to tier 0? So we'll cover this a little bit, but tier 0 is different in AWS than it is in Active Directory. So we've had a lot of discourse on what tier 0 means, and we could call this anything. I mean, I kind of picked tier 0 because it's the nomenclature that we've already been using. Well, we could call it admins. We can call it gold, platinum, status, select. I don't care, right? just whatever, whatever that most privileged core of your environment is. So there are two reasons why building this out is difficult, right? And the first of which is this idea of resultant set of policy, and that's a Microsoft term too, but it's this idea that you can have conflicting statements on a given principle. So a principle might say, or a policy might say you can do X number of actions on Y set of resources, and then another statement says you can do a subset of X on a subset of Y, or that's denied. And so there has to be this synthesis of like, what can I actually do? After all is said and done, after all the deny statements are taken into account, after all the conditions are solved, what can I actually do, right? So that's the resultant set of policy. That's the first difficult problem. And then there's this idea of conditions, right? So a lot of statements, I've seen some AWS environments never use a single condition. And then there's other AWS environments that are like attribute-based access control that are all conditions, right? So it's really environment specific, but we need to be able to demonstrate or to show to the user that this attack path is conditional, right? Some things have to be true for this attack path to exist, right? And that's a pretty difficult problem to solve. And so you might be wondering, well, hasn't this been done before? And kind of, right? And even if it has, we still want it in our own graph so that we can answer some bigger questions that we'll talk about later. But they have been kind of done before. So AWS will let you simulate. So there's like an access simulator. They'll let you simulate individual calls from an individual resource. From an individual principal on a set of resources. But we don't want that. I don't want to sit there at a terminal and say, can user A do this? Can user B do this? Can role C do this? I want to know all the users that can do all the things on all the stuff, right? And then about an hour ago, thanks Lee, I learned about Zelkova. I just threw that in there real quick. So AWS, this is something that AWS has been tackling internally, but it hasn't been externalized yet to my knowledge, although I do want to do a little more research on that. And then there's Access Advisor. And I'll have a screenshot of why we kind of want to dig deeper than what Access Advisor is giving us, and Policy Simulator as well, right? So it has been done in parts, but we kind of we want to do it to solve to serve our purposes. And specifically, we want to be able to solve this offline, right? So if we're, from an attacker's perspective, if we get that account authorization details, that JSON file, we want to be able to take it offline and do our analysis without making a bunch of calls to AWS, right? So we have kind of like 6 big questions. And I say there are 3 because they're kind of like inverses of each other, right? So the first is, given a resource, what principles can perform what actions on that resource? So I want definitive. I don't want I want, resultant set of policy, conditions solved, SEP, everything applied. What can this, what users can perform what actions on this exact resource? And then conversely, given a principle, what are all the things it can do? And this is actually not a tough problem. It's difficult to present that information in a usable way, right? Because there's about 20,000 actions in AWS, right? And so I'm not going to give you a list of 18,000 actions and then a matrix with 20,000 resources. That's not feasible, right? So having a clean way to display that has been a challenge. And then secondly, we want to know what roles can a principal assume and what principals can assume a role. So inbound and outbound roles. So if you're familiar with Bloodhound, this would be similar to users, like your identity chaining, right? So AWS provides a way to a transitive identity function by role assumption, and we'll take advantage of that in our attack paths. And they often do take part in our attack paths, right? We're usually chaining role assumptions from A to B to C. Lastly, the third question is, what principles are tier 0 and what identity paths are tier 0? And we'll get into how we define tier 0 in just a sec. So I didn't want to leave too many people in the dust. If you're new with AWS and you have no idea what I'm talking about, I want to spend 2 slides just to cover some of the basics so that you can follow along. So the key things with AWS permissions is that you have these sets of principals. So you have users, roles, and groups, and they get their privileges from policies that are attached to them, right? And so a policy, or I'm sorry, a role or a user can have 0 or more policies attached to them, and each policy has 1 or more statement with allow and deny, right? And the whole point here, and this is the big contrast to Active Directory, is that if you don't have a principal attached to you, you can do absolutely nothing. You can't even figure out what you can do if you don't have any policies attached. No API call will succeed, right? And so everything has to be explicitly permitted. And then the second is that if there's a conflicting statement, deny always overrides. So this isn't a firewall kind of scenario where the first rule takes precedence. Deny always takes precedence, right? So if you're to look at an actual AWS policy, it's kind of structured like this. And there's some stuff that we won't really care so much about, but the 3 main takeaways is that there's an effect, an action, and a resource, right? So the effect is either allow or deny. It's one of those 2, right? And then the action is the things that you can do, and then the resources on which resources are you acting on, right? So pretty straightforward. So in this case, we have an example resource. An example policy. And what this says is you can call EC2 get anything on any EC2 instance that has the letters ZZZ in it. And the things I want to highlight here is that you can use this asterisk as a wildcard. So all of a sudden our conditional, our policy evaluation needs to take into account wildcard expansion, right? So now we're doing a lot of string matching, which becomes even more difficult, right? So in this case, this is an example of resultant set of policies. So we might have one statement that says you can call EC2 get star, so that means like get EC2 instance, get instance profile, whatever. If it starts with get, you can call it on any EC2 instance that has the letter ZZZ. But then you could say, but I want to deny get console output specifically for any instance that has ZZZ CCC in it. So now we kind of have like this hole in our matrix that we can't call, right? And we need to be able to model that up in our graph, right? So it's at this point where we are like, okay, this is starting to feel like a graph problem. You could see like if it was any other of these EC2 function calls, we can call, they would succeed on all 3 of these, but specifically get console output on ZZZ CCC is blocked, right? So hopefully we're tracking. So then we wanted to model this up. And our first thought was, okay, well, let's just throw this into Bloodhound, right? That's easy. And it turns out that because of these, just the granular nature of AWS in general, it became clear that this is more of a research project. This is something that we wanted to spend time on, like, let's figure out what this problem is before we make any big engineering efforts to like integrate it into something else, right? And that's really what this is. Apeman is, I think, either like the 3rd or 4th iteration of this prototype of trying to model up this path, this attack path finder, right? And the cool part with this is, unlike Bloodhound, we don't need a collector. We don't need an agent running on any device. We can just make these API calls to AWS. We can even say, hey, get us this JSON file, and we'll ingest it from there, and we can extrapolate everything. Because unlike Active Directory environments, every single resource is tracked in AWS, right? Because they want to bill you for it, right? So we have a really clear, nicely defined manifest where we can make very concrete decisions on what a user can do. So for example, if a policy says resource star and we get all the ARNs in that account, we know what star is. We know what everything is because we have that manifest of all the ARNs, right? So we can make definitive, we can define our universe in this graph and say this is definitively our universe, right? Yeah, sure.
So, what happens if, rather, what privileges are necessary to run that? And what happens if the person that you asked to run it for you runs it with the wrong privileges?
Oh, good question. So the question was what privileges are required to run that? There is a specific, so that the call is get account authorization details. So whatever role that you're using to collect that needs to have specifically that action listed in some policy, right? And if they don't have that permission, then it won't succeed. Kind of to my point where if you don't have permissions to call it, then some policy has to say you can call get account authorization details. So usually it would be like a read-only role or something like that.
So is it possible to run that and have the results have holes in it that you're not aware of?
No. It'll never, so the question was, is it possible to run it and get holes, like get missing data in the output? And the answer is, oh, you say kind of?
Well, if you have a policy that says on an exception for a resource, you could write a policy that could explicitly exclude like potentially admin accounts.
Yeah, with get account authorization details, it's not going to give you the ARNs of like your lambdas and your EC2s and whatever. It's just the IAM, right? What's up?
If we could hold questions until we
okay.
towards the end of the speak.
Yeah, I'll clear that up towards the end too.
We'll have time for questions afterwards. Thank you very much.
Okay, cool. Yeah, and so we started to build out this graph, and I think this is kind of like the key or the nugget of Apeman and what gives us the power to solve these questions, right? So we've got kind of usual suspects: group, user, role. I know you can't read this, apologies, but we have managed policies and inline role policies, and this is kind of like how things are defined in AWS. And then underneath, so this is the bottom half of the graph, everything kind of stems from the statement. So the statement is kind of the atomic block of our permission model, and then everything goes from there. So another key takeaway here is that when you use a wildcard like a star, we actually create a node for that. So if you say like EC2 star, there's a node for that, and then that will expand out to every EC2 action that AWS defines. And AWS has documentation for all of the actions and all of the resource types and everything. And then I kind of want to highlight this one. This is really like the linchpin of why we can make these queries and make them performant, is because there's this resource type that that AWS defines. So when you have like an action, let's say create instance. And so let's say my policy is create instance on resource star. Obviously, it doesn't make sense that I would call create instance on an S3 bucket or a Lambda function. So that star isn't really every resource. It's like every resource that makes sense. And what AWS does is they say, there's actually a specific set of resource types that this can act on. So when we expand out these wildcards, they actually don't create all the edges to all the things. We can make very educated like edges to only the things they apply to, and that keeps it pretty performant. And then the last part of this graph is the conditions. We have to be able to model up conditions, right? So altogether, this is our graph. And with this graph, we could answer all of those 6 questions that we mentioned earlier, right? And we could stop here. We could just say, here's our graph, you figure out the Cypher queries, you answer your own questions. But we didn't want to do that. We wanted to have a way to present useful information to you so that you didn't have to learn Cypher, right? Similar with Bloodhound, right? So we're going to go through kind of a concrete example, then I'll do a demo. So in this case, let's say we have 2 roles. We have Lambda admin prod and Lambda admin dev. And Lambda admin prod has a Lambda admin policy, which acts on this Lambda function called prod user authentication. And then we have a Lambda dev policy that's additionally attached to Lambda admin dev. So that has 2 policies attached to it, but they both act on prod user authentication, right? And those policies look like this. So the first one is really simple. It says you can do any Lambda action on any resource. And we know because of like resource types, that's not any resource, it's just any Lambda resource. And then we have a deny statement saying, I don't want you to do any write operations if the function starts with the word, I know you probably can't read this, if the function starts with the word prod. And that's a really common pattern that we've seen is grant a lot of things and then deny access to maybe something sensitive like the word prod, right? So this is a fairly realistic example. So our pseudo query would look like this. We'd say, so it's kind of a pain actually, and the query itself is a nightmare. And I haven't mentioned this yet, but we're actually not making raw Cypher queries. We're using this API that the Bloodhound engineering team created called Dogs, which is an abstraction layer that kind of lets us use whatever database on the back end. So eventually we could use like Postgres or whatever. So in Dogs, we'll say, give me all the statements that have the target resource and scope. So let's forget about users, let's forget about roles. Give me every statement in this graph where that prod user authentication Lambda function is resolvable as a resource. And, like all allows, all denies, whatever. As long as it's in the resource, we'll give it to me. So now we have this bundle of statements. And I say, okay, well, give me all the effective statements. And that means if the statement is like EC2 star and resource star, that would resolve in the first one, but it wouldn't resolve in the second because EC2 can't act on a Lambda function. So I'm saying, give me, of all those statements, give me all the statements that have an action where I can actually act on this Lambda function. So those will be our effective statements. And then from the effective statements, we have to crawl up the graph and say, give me all the principles that have this statement attached to them in some policy. And then we have to go through each principle and say, do you deny this? Like, is there a mix? So we actually do 4 matrices. We do matrices. We do a allow matrix, a conditional allow matrix, a conditional deny matrix, and a deny matrix, right? And then we flag it if it's conditional. So this is what it looks like in IAM policy simulator. And I kind of want to highlight why this is an incomplete view. So this is the role. So this is in my test account. And we have our 2 policies attached, deny write and lambda admin. And you'll see here for resource star, it says everything's allowed, which we know is not, it's not wrong, but it's not right? It's incomplete. The information is incomplete, and that's what we want to solve. So let's check out a demo, and I'll kind of show you how we solve this in Apeman. Let's hop in. Okay. So don't be overwhelmed by the amount of information on the screen here. We got, so let's look up, was it prod, user, let's clear this out. Prod, user, authentication. So this is our Lambda function, right? And it's getting its inbound. So this is our resultant set of policy. So this is after all the deny statements are taken into account. This is the list of users that can perform unaction on this, right? And a lot of times what we'll do is we'll say, like, we'd be evaluating these and I'll see like that admin policy is attached to a role I'm interested in, and I'll forget that there's multiple, right? So in this case, I would say, okay, let me filter out, let me look for any of these that have create function, right? And we have, here's all my list of roles of create function. Or I'm sorry, all the principles that can call create function on this resource. And I'm wondering, okay, well, where's lambda admin dev? Lambda admin dev has lambda admin policy. Why can't it write to this? So what we can do is, let's close this out. I can't see my mouse. We can do pathfinding, right? So I tried to model this like some popular map programs online, and it should look kind of like Bloodhound a little bit. But we have these path selectors here, right? So because of the way we did our graph, it doesn't always make sense to do shortest path. So we have an identity path, permission path, shortest path. So we want a permission path. So we're going to say lambda admin dev. Where are we at? If I could type. So let's go to lambda admin dev. And I want to do a path, a permission path to prod user auth. Okay. And of course, it puts this out here. So this is the resource, and we'll immediately see why. This is why we're getting blocked, because we have two paths. One, you could see all the way out. So we have a policy, and this is the version. So of course, like AWS has to make things complicated, and we have like version policies. This is the policy document. This is the statement, and so it says this statement acts on this resource, and that's an allow. So green is an allow, red is a deny. So we see that there's a deny statement on this, so we already know. So we can click on this, and it'll say exactly, you have deny actions on this resource, and that's why we can't call create function, right? So when I was modeling this out, actually I was getting this talk ready a couple days ago, and there's a demo later on where we're doing assume role, and I was wondering like, why the hell can't A call B call C? This exact thing came up. So I was actually able to use this functionality debugging this talk, which I think is pretty cool. So that's demo one. So that answers our first two questions effectively. And then we have the idea of role chaining. So role chaining, if you're new to AWS, the idea here is that a role can get credentials for another role and assume that role, right? So there's a function called STS assume role. And assume role with SAML, and assume role with web identity. But the idea is that a role can change its permission set. And this is a built-in feature for AWS, right? So in this case, there's actually two policies that have to be evaluated, a permission policy and a resource policy. And the resource policy is a special one called a trust policy. So it's not enough that role A has permissions to assume role B. Role B has to explicitly say, I trust role A to assume me, right? And all the same things hold true for this. You can use wildcards. You can specify multiple accounts, multiple roles, whatever. But this trust has to be set up. So that's something that we have to evaluate when we calculate who can assume what, right? But here's the really cool part, and something that sets it apart from Active Directory and Entra is that they don't have to be in the same account. They can be a completely separate AWS account, right? And there's no key exchange that happens. There's no trust that has to be set up. All you have to do is specify a different account number. And of course, like role B in the other account has to say, I trust this account to assume me, but there's no more mechanism there. That's it, right? And you'll see this a lot in client environments where they have like maybe a dev account that goes to a staging account that goes to a prod account. Like these are built-in features that we can abuse, right? So let's take a look at how we do assume role. So we have, and I think I'm stealing from Bloodhound terminology, but it's a post-process edge. And the idea there is that these edges that you're going to see are not, they're not structural. Like there's no document that defines it. We infer it from the privileges that we evaluate. So if we go to our identity path, I'll just show you, here's a quick example. So we have A role, right? And I want to know if A role can get to C role. And you'll see here we have our can assumes that kind of build this out, right? And these are bigger edges because you can click on them. I mean, not right now because this is a demo and I'm not going to try it. But ideally, you click on it and it would show you exactly why you can assume, right? So here are the statements that say, here's the trust policy statement, here's the assume role policy statement, et cetera, right? So we have that part solved, or mostly solved. We're still working on conditions. So we can do our role assumptions, and we've got our sub figured out. So now the fun part begins, right? We've arrived at the start. We can now start solving really interesting problems. Like going back to a couple years ago, what is tier 0? How do we even define what this admin policy is that we want to path towards? Like you can't really have an attack path if you don't know where you're going, right? And Alad had a really good observation when we were talking about this, that AWS is not about identity. It's about policy, right? I mean, identity in the big term, but when we're focusing on the mechanics, it's about policy. So an example is, you might have an identity provider hooked up in your AWS, so you could say like, my identity provider can assume a role. If you compromise that identity provider, you only really compromise the specific roles that identity provider is trusted to. So it's not the end-all be-all of the account. And so the first question was, okay, well, at first glance, what's admin? And you'd say, well, AWS gives you this administrator policy. It's an action star on resource star. That seems pretty obvious. That seems like a good start for admin. And then the next silly question is, okay, well, let's say I have action star, resource star, but I deny bracket star on resource star. And brackets like some quantum computing API or something. Actually, I don't know what bracket is. But the point is if I give you everything and then I take away a little bit, are you still admin? It's like, yeah, you could still take over this account. You're still admin. And then obviously you could probably see where I'm going with this. How much can we whittle away before it's not tier 0 or it's not admin? Or more properly put, what does it mean to be admin? What is the essence of it? And so we kind of came down to this first definition. And it's going to be probably the first of many, which is, what's the bare minimum that I can have where I can guarantee an account takeover, right? And we came to attach role policy and detach role policy and the ability to authenticate as the principal where we can attach and detach that role policy. And the reason why this is because, remember, deny takes precedence. So if we can detach any deny policies and attach all the policies we want, then we are guaranteed account takeover. And for the time being, let's just, when I say attach role policy, detach role policy, that is resultant set of policy. So that means that you passed all your SCPs and your session-based policies. If you can call these things on a principal and you can assume that principal, you are guaranteed to take over that account, right? And that's just a very narrow definition, and we want there to be more, right? This is where we want to expand research and say, here's the list of all known guaranteed takeovers of an account, right? And the cool part is what we're talking about is not context specific, but of course, any AWS environment can have their own context specific tier 0. So similar to Bloodhound, you could say, well, I know that there are sensitive creds in this S3 bucket, so I'm going to mark read access on this S3 bucket as tier 0. And that's fine. You can define that, and then you can build your paths to that action resource combo, right? And then more importantly, we have this subset of our tier 0 definition, which is self-contained. And what that means is that a principal can attach and detach policies on themselves. And so if you have a principal that can attach and detach policies on themselves, then you are tier 0. And this is just kind of a flex brag. But this is I was excited about this because this is the first time we actually got to use Apeman, and it actually provided valuable results. But we had a client that had all these AWS roles, and they had this one that they called admin, right? And admin had a specific deny statement on it saying, if your name is admin, you can't attach or detach policies to yourself because it's admin, and the word admin is scary. And they said, okay, I don't want admin changing their permissions, which is fair. But then there was a dozen other roles that can attach and detach policies to themselves and effectively take over the account. So in effect, of these maybe dozen or so roles, the admin was the least privileged because it was the only one that couldn't take over the account because they had other deny statements attached to them that would block specific IAM things, right? And that was identified with Apeman because we ran that query saying, okay, give me all the roles that can perform these actions, right? And then it gets really interesting. And this is where I think the bulk of our research is going forward. So this is not something that's implemented in Bloodhound yet. But we have this idea of tier 0 paths. And the idea is that a principal can be tier 0, but so can a path. And that means a path in aggregate. So maybe one principal of this path can do part of the tier 0 escalation, and another principal can do part of it, and another principal can do part of it. And in aggregate, they can be tier 0, which I think is a really fun and difficult problem to solve, right? And we can do it manually, and I know that we can solve this with Cypher, but we want to do it in a way that's performant. So I'll give you an example. How am I doing on time? Good? Okay, cool. Plenty of time. I think we're doing all right. So let's say we have an account A, and we have a role called Jenkins Dev. And Jenkins Dev can assume CloudFormation prod, right? And I gave these real names to make it feel a little more real instead of like ZZZ. And then CloudFormation prod can assume read-only role, and they can also attach a role policy to that. And Jenkins Dev can also assume Jenkins staging, which can assume Terraform prod, which can call detach role policy on this read-only role. So over the span of 3 separate accounts, we can build out a path that's tier 0 on this read-only role, because at this point, we can attach and detach arbitrary policies to read-only role and take over our account C, which is like our, let's say it's our production account, right? So I'm gonna get into the last demo here, which is just showing off the tier 0 access. So, and forgive me, I'm not a UI dev, and this UI will change. So here, like in every account, we'll have a list of the direct tier 0 principles. So these are principles that have this tier 0 access. But on top of that, we have our indirect, right? So this should feel pretty familiar. And for any one of these, I'm going to pick on A role again. We can graph them out. Well, let's do a different one. Let's do admin. Oh, let's do A role. We can graph them out and see why A role is a tier 0 role, right? We can graph out more. Let's do tier 0 part 1. I actually don't know what this is going to show. Oh, it can just assume C role. Okay. Well, that's not fun. All right, but that's the point, is that we can demonstrate or we can show why specific roles are tier 0 in the account, and that'll give us a good clue on, which roles we want to attack from an attacker's perspective, and of course from a defender's perspective, you want to know your paths incoming to your privilege principles, right? So at this point, once we get all this working, so I plan on releasing Apeman, putting it on GitHub, open sourcing it within the next few months. I want it out before August. But at that point, I feel like the real work begins. So we have this tool to map all this stuff out, and then we have really cool research, right? So we want to have a way to categorize access in any given account. And we want our like, my dream is to have like this JSON set that's in a public repository saying, here's all of the known tier 0 paths or tier 0 combinations for AWS that you can ingest and run. And we want to have context templates. So actually, I'm going to show you one quick thing real quick. I know we're running low. I cut a section on conditional access. But as a part of this, so like any one of these policies can have conditions attached to them, right? And that makes it really difficult because we might have a path from A role to B role, but we need a way to say, this isn't guaranteed. Certain conditions have to be met for this to happen, right? And some of those conditions can be resolved. Like, for example, if we're comparing like a policy tag, like on role A, we can do that at graph time. We could say, the tag on role A matches the tag that's being inspected in the condition, but sometimes conditions can't be resolved. It might be something like the IP address has to be this, or the time has to be this. And so what we'll have, or what we do have, is a context manager to kind of fill in those variables. So over here, we're gonna go through and we evaluate every statement, and we look at the condition keys that are being used and we populate them in this list. And then we say, you can override these so that we can actually resolve these conditions. And how I see that being useful is that if you deploy this in your environment, you can actually define templates. You could say like, this context state is my developer template, and this context state is my DevOps template, or my workstation template, or whatever, right? And so when I referenced that in the slide, that's kind of what I meant, is that we'll have these context templates where you can define attack paths from different norms in your environment. And then lastly, we just want to expand the vocabulary for discussing AWS attack paths. So having a consistent way to talk about this is our goal. So next steps, one of the things that we engineered for, but we just haven't implemented yet, is SCPs, session policies. Those are really easy from our graph model. We just have to program them up. Our condition resolver engine, there's a lot of work to do there, but we're getting there. UI needs to be a little bit better, and then just like productizing, like unit test, testing, releasing, and then our plan is to have it out before August. So yeah, I think that's about it. And I'll take any quick questions if you have. How are we doing on time?
We're doing great. We've got about 8 minutes for questions. So if you have a question, I will run over with the mic to you.
Yeah, sure. John.
Sorry. With respect to the concept of effective or aggregate tier 0, is that something that you've seen or heard of attackers exploiting in the wild to do an account takeover?
This is another humble, not so humble brag flex, but we've done it. So because that was the original reason why it came up, was that we had one environment where it wasn't tier 0, like guaranteed, like it wasn't attach role, detach role, but in aggregate, this path got us the access we needed to act on it was like a Lambda function that was running in a privileged context that we then abused. So in this aggregate of paths, we got a write primitive out of it. So yeah, we've done it. I can't speak to if like legit attackers are doing it, but it's also something I'd want to know in a network I'm defending. For sure.
Anyone else?
So is any of the activity that you conduct during this enumeration phase, or even like taking ownership of certain roles, is that stuff first auditable in CloudTrail or something like that? And then does like Amazon's logic detect like, hey, somebody's doing enumeration of key roles or something like that? Is there any kind of detection going on?
Yeah, there's no doubt that you can write alerts to detect on that. So so Apeman ingests that account authorization details document. That's just one API call, right? So it's one API call to get all of the IAM stuff. And then like, depending on how you want to enumerate the rest of the resources, like there's, I forget what I used. It wasn't config, but it was something similar to get the rest of the ARNs. You can do it however you want, but yeah, you can alert on that for sure. And like I said, if you are privileged enough to call get account authorization details, like that's not something that I've seen pretty prevalent in most accounts. So that's already pretty privileged. So I wouldn't call this a defender tool because it's useful for attackers, but I might say that the utility for this is probably more useful for a defender. But all that to say too, if you even get a little bit of this data, you could always just throw it in Apeman. Like Apeman is opportunistic. It's not going to require that you have the whole picture. It'll infer these relationships on whatever nodes it has. So, and then yeah, with the role assumption stuff, like that's something we talk about a lot. Is a lot of times with our attack paths, you'll have like role A goes to role B goes to role C. It'll often be the first time that chain has ever happened. So what we'll say is like, it's helpful to write alerts to say like, is this the first time role B has ever assumed role C? If that's the case, then like maybe just tell someone that this has happened for the first time, right? Yeah.
Okay, Daniel, thank you very much for speaking.
Thanks, y'all.
Let's give him a round of applause.